Hello, I'm Ted Dangelmeyer with Dangelmeyer Associates, and this demonstration is on static induction and double jeopardy. And I have to tell you that personally I found this to be a very confusing topic and had to see it explained several different ways before I really internalized what it meant. So if you don't fully understand it after this demonstration, you'll be in very good company because it's been true of a lot of people. In fact, because of my experience, I've represented and explained ESD induction in my book in several different ways, so that you can see it in different ways of presenting it. Now, to my right, I have an image that we're going to use to show you the induction and the double jeopardy scenario. What we have here is a disk that at the moment is not charged. And over here we have a source. It's a positively charged source radiating an associated field. Now, as this metal sphere comes toward that charged source, you'll see that it begins to polarize. You can see that the positive charges have been repelled and negative attracted to this source. As it gets closer, you'll see that the polarization amplifies. It becomes more intense, stronger, if you will. And again, it's that function of distance. As you get closer to a charged object, it has a greater opportunity to induce a higher potential on the item. Now, at this point, if we discharge the conductor here, you'll see that effectively the positive ion charges have been driven away to ground. Now, if we pull the charged source or separate the charged source from this metal disc, you'll see that it is still charged. There's still a charge residing on this disc, which means if we, even though this is now effectively out of the scenario, this disk is still charged. And if we ground it now, we'll get a second discharge, which is commonly referred to as double jeopardy. Now, again, this is a confusing topic, but let me demonstrate it, and then I'll come back to this again, so we'll go through it one more time. Let me just back up to the beginning, so we'll be ready for that. Okay, so now what I'm going to do here, we're going back to this metal plate, and we're going to create this double jeopardy through induction. And I've turned on the data acquisition system. And what I'm going to, I have the event detector set to sound an audible tone when we see a discharge. And I'm going to use this defective pair of tweezers that we spoke of in another demonstration. So I'm going to charge the insulator and place it on the surface. Now you can see on the scale here that what we have is, in fact, it's, in this case, it's about 300 volts, not a huge source. But what I'm going to do now is discharge it with this pair of tweezers. But note, up until this point, we have not heard a discharge. We discharged it. And now it appears, based on the data, that that disk is not charged. It gives you the illusion that it's no longer charged. Well, now watch what happens when, in fact, what do you think is going to happen when I remove this insulator? Well, it goes back to being charged at the opposite polarity and nearly equal and opposite. But we still didn't hear a discharge when that potential rose. Now what I'm going to do is discharge it again. And now you see that there was a second discharge. So with the same charging mechanism, we got two discharges. That's known as double jeopardy. Let's go back to the slide again. Bear with me. Here we have this same slide that we started with. Again, this is a metal disc, and it's going to be approaching this charge source, like we did with the insulator here a few minutes ago. So here we go. We bring the two of them together, And as they approach, you start to see the polarization. As they get closer, the charging or the induction gets stronger. That's the same as this stage, where the metal plate was in contact with this insulator. Now, if we discharge it, as you see here in the schematic, there's a removal of charge. And if we touch the metal plate, that's mechanically the same thing that you see here. Now, at this stage, on the graph that you saw a minute ago, we had what appeared to be 0 volts on the metal plate. That's what you would see until you separate the two. Separate the metal object from the insulator, as I did earlier. I took away the insulator, and now you see that the plate is charged to an equal and opposite polarity. Therefore, if I ground the plate again, we get another discharge, which is represented here schematically with the animation. Where we bring another ground in, we get the second discharge, known as double jeopardy. Now, what is this all about? Well, it's a confusing topic, and we see double jeopardy happening within the factory in a variety of ways. We've seen it in, as an example, automated test handlers, where there are plastic elements within the handler, devices coming through, getting charged once, discharged, and then discharged again. So it's a real phenomenon that does occur, and again, gives you two stresses for the same source of charging. Very important scenario to fully understand so that you can implement it effectively in the factory. And this concludes the demonstration, and again, I thank you for your time.